Hello guys, we are discussing chapter number 7, properties of sound wave. So let's start our discussion with the problem number 1, which states the sound from a trumpet travels at a speed of 3.5 into 10 raised to power 2 meter per second in air. If the frequency of the note played is 3 into 10 raised to power 2 hertz, what is the wavelength of the sound wave? So the speed of sound is given, the frequency of the sound is given, we have to find out the wavelength, and for that we can use the universal wave equation V is equal to f lambda. Now from here what we can represent the lambda as, lambda will be V upon f. Now V is given, so lambda will be equal to 3.5 into 10 raised to power 2 meter per second upon the frequency, which is 3.0 into 10 raised to power 2 hertz. So when you compute it, it will be coming out to be equal to 1.2 meter, and this is the wavelength of the wave. So now coming to the next question, it states calculate the speed of sound in air when the temperature is 16 degrees Celsius. So temperature is given, we have to find out the speed of sound. So speed of sound is given by the formula 332 meter per second plus 0.59 meter per second upon degree Celsius into temperature. So V will be equal to 332 meter per second plus 0.59 meter per second per degree Celsius into the temperature, which is 16 degrees Celsius, right? So when you do the computation, it will come out to be equal to V is equal to 341 meter per second. Now coming to the next question, it states a ship is anchored where the depth of the water is 120 meter and ultrasonic signal sent to the bottom of the lake returns in 0.16 second. What is the speed of sound in water? When we need to find out the speed of sound, which formula we will be using? The total distance traveled upon the total time taken. What is the total distance traveled? The depth of the water surface is given, right? So bottom of the lake is at 120 meter, right? But the signal is going towards the bottom and it will be coming back, right? So the time is taken for the signal to be going at the bottom, and from bottom it will be reflecting and coming at the upside location. So if this is D and this is also D, the total distance traveled will be equal to 2D, which is 240 meter. So now V will be equal to delta D upon delta T. So what is delta D? We have calculated 240 meter. What is delta T? It is 0.16 second. This is the time which is given, so it will be equal to 1.5 into 10 raised to power 3 meter per second is my velocity, right? So I hope you understood that question as well. Now coming to the next problem, it states a tuning fork with a frequency of 256 hertz. It sounded together on a note played on piano. So we have two frequencies over here. 9 beats are heard in 3 seconds. What is the frequency of the piano? Right, so beat frequency. What is the beat frequency? Beat frequency is the number of beats per second. If I know the total number of beats, if I know the total time, I can divide them, and this is how I can get the beat frequency. What is the total number of beats? 9 beats are heard in 3 seconds. So total number of beats are 9 and the total time is 3 seconds. So beat frequency will be equal to 3 hertz, right? So now beat frequency, here you can put the unit as well. So beat frequency is equal to difference of the two frequencies and their mod. So if I am having f1 is equal to 256, so f2 is in such a manner that the difference of f1 and f2 is 3. So now f1 minus f2 is equal to 3. So let's put f1 is 256 minus f2 is equal to 3. So when I take f2 is equal to 259, f2 is equal to 259, I will be having the difference of the frequency to be equal to 3 and their mod to be equal to 3. So now coming to the next problem, it states a car traveling at 100 km per hour sounds its horn at it as it approaches a hiker standing on the highway. If the car's horn has a frequency 440 hertz and the temperature of the air is 0 degrees Celsius, what is the frequency of sound wave reaching the hiker as the car approaches after it has passed the hiker? Right, so here we are given two situations, when the car is approaching the hiker, and second situation, it is moving away from the hiker. So now we know the frequency formula. when the source is moving, frequency is equal to f1 v upon v plus minus vs, right? This formula we know. So now f1 we know v, we know vs. Now when the car is approaching the hiker, we will be taking v minus vs in the denominator. So f2 will be equal to f1. What is f1? We are going to put the values only. So 440 upon what is v? It is 332 meter per second upon 332 minus vs. It is 100 kilometer per hour, and 100 kilometer per hour can be represented as 27.8 meter per second, right? So here in the denominator we have to take a negative sign. Now you can do the computations and it will come out to be equal to 4.8 into 10 raised to power 2 hertz. This is my f2, right? In the next case, when the car has passed the hiker and it is moving away from the hiker, in the denominator we have to take the positive, right? So f2 will be equal to f1, which is 440. What is v? It is 332 upon 332. Here we will be having plus and 27.8. Again you can compute it with the help of the calculator and it will come out to be equal to 4.0 into 10 raised to power 2 hertz. Right, so I hope you understood both of the cases. Now coming to the next problem, it states the speed of sound at the sea level and at 0 degrees Celsius is 332 meter per second or approximately 1200 kilometer per hour. At an altitude of 10 kilometer, it is approximately 1060 kilometer per hour. So speed of sound is varying at the altitude and it is 1060 at 10 kilometer altitude. What is the Mach number of an aircraft flying at the 10 kilometer with the speed 1800 kilometer per hour? So we have now the speed of sound at 10 kilometer height. We now know what is the speed of aircraft at the 10 kilometer height. So Mach number is given as the speed of object divided by speed of sound, right? So 1800 is the speed of object in kilometer per hour and 1060 kilometer per hour is the speed of sound. So when you divide it, you will be getting 1.7. So Mach number for this aircraft is 1.7. So I hope you understood all of the problems. Thank you so much.